Hi, welcome back to the CSR House project. One of the aims of the CSR House is to create a sustainable, energy-efficient home that's still going to look modern and attractive. The external cladding is a large part of a house's personality, so it needs to have that contemporary look, but perform thermally as well. We're using a composite of cladding materials to create that distinctive exterior style. With so many options to choose from, you can go for face brick, rendered masonry walls, fibrous cement panels, weatherboards, or even stone. How do you choose the best material for the location and function of a wall? And why go for a composite look anyway? Here's Gareth to tell us why.
The reason we chose composite materials for the outside of the building was, one, because we wanted to display a variety of the CSR products, but also so that we could experiment with the thermal performance of each of them in various situations on the building.
With the cladding options, CSR has a very wide range of products that can be used for external cladding on houses. The upstairs, we chose the 7-tall designer series, and for the cladding options on the downstairs area, we chose the Hebel Power Wall.
We're aiming for an 8-star energy rating, so it's important to choose products that are high achievers in the efficiency stakes, but also have excellent environmental credentials.
Hebel is autoclaved aerated concrete, manufactured from sand, cement, lime, gypsum and aerating agents. Each Hebel power panel is reinforced with specially coated steel mesh, making it incredibly strong and durable. Then cut to shape in various lengths and profiles and steam pressure cured in an autoclave. Hebel provides an attractive modern exterior with all the energy performance we need.
Hebel's a fantastic wall cladding system. This is Hebel Power Panel. These come in 600 wide panels in varying lengths from 2.4 up to 3 metres. They're a 75mm autoclaved concrete. It's very easy to store on site. It comes as a palletised modular form. There's less wastage on site because you can accurately determine how much product you need. You can use conventional power tools, so a circular saw with a power tip blade. Carpenters generally install the product, so it eliminates the need for the trades on site. What we do is spend a bit of effort to make sure that the frame is true and plumb, and then we use a top hat section that we run horizontally across the frame. In our case, we use a 25mm top hat section, but it can go up to a 40mm. So
everybody see that tapping out, that top hat as well, so things aren't perfectly plumb, so it's not the best case scenario.
A bit more adjustment between the panels. The panels are then screw fixed into place, and a proprietary adhesive is applied to the joints, and they're butt jointed together. That adhesive is then sanded off before it dries, and then an acrylic-based render is applied over the top. The render produces a fantastic monolithic rendered finish to the panels, and I've really enjoyed working with it. It's been a great product.
Hebel is non-combustible and it has very strong and high fire resistance properties. It can achieve up to a FRL of 240 minutes, and what that means is it's also a perfect solution for building in bushfire-prone areas. Hebel complies with all 6 bushfire type level requirements across the country.
The Hebel Power Wall has a much better thermal performance than other masonry cladding options. You get a...
So everybody understands the bushfire type levels? So, yeah.
0.3, 0.5 boosts of your R value over equivalent wall systems.
It has 61% less embodied energy than concrete and 64% less embodied energy than brick veneer. Hebel is a quarter of the weight of traditional masonry, and what our steel reinforced power panels do is they actually pass that critical knock test. What our consumer research has shown us is that many homeowners these days are highly driven and motivated by design, and that's what attracts them to Hebel, because it allows them to be able to achieve that design freedom and flexibility in their home.
Hebel gives a great finish on the lower level, but on the upper level we needed a product that was going to complement the solid contemporary look of Hebel, but be lightweight and durable.
7-tall designer series is installed as a complete finished wall system. The panels are tongue and groove profiled along the top and bottom, so they fit neatly together to form a waterproof joint. It also features a ventilated and drain cavity, which is a proven and highly effective method of waterproofing buildings.
The Cementel Designer Series is a pre-finished walling system that looks great, is quick and easy to install, and has all the reliability you'd expect from a CSR system. The product's actually made of a cement composite material, which is actually lighter and easy to work with than standard cellulose fibre cement. Although it's lighter than standard fibre cement, it has the same properties, so it's termite resistant and won't rot. The Designer Series comes in a range of textures and colours, which makes it great for standalone design or in combination with a number of different facade materials, such as a composite construction, which is the CSR house. No finishing is required, so essentially all the products have a multi-layer coating, which is designed for long-lasting colour performance. The coating also has an inbuilt property which prevents dust and dirt adhering to the panels, which means that maintenance simply consists of spraying down the wall once you go with a simple garden hose.
The Cementel Designer Series fixing system is totally unique. Preparation is key to affordability and a successful Designer Series install.
Carpenters can do the whole installation from framing and then cladding the wall itself. The boards come in 3030 metres in length and they're 455 is the effective colour. The installation of the board is very easy to achieve. There's a starter strip fixed in the bottom of the frame. You level that off and then the boards are held onto place with that. The boards have preformed corner pieces which go in and then a sealant joist applied between them or in between boards. And as you can see that that sealant joint works very well. It's very hard to distinguish between that and the board itself. Rather than conventional coating systems that are fixed direct to the studs, this has got a 15mm cavity which allows for ventilation of the wall system.
Where we're using the Cementel products, the new display ones, panels, that's being used as feature panels in the lower levels, and it's very, very attractive finish for looking like a stack stone finish. There is a huge advantage in using the integrated products on a building site. One, because you've got one manufacturer delivering the product, so it's simple. Two, because you've got trades who understand the product and put it together quickly. I mean, the Hebel product we do exclusively on most of our buildings now because we find that the product is so simple and quick to erect. The tradesmen who do it are putting the floor down as a simple product. You simply plug.
So that's another application of it. So you've got your Hebel power panel for walls, your 75mm, and then you can use that same 75mm for your flooring as well, or you can use thicker panels for larger spans. So you've got span tables. I think your 150 panels will span something like about 6 metres, so they'll do a very large. It all depends on what loading you have, and you don't want to go parking a piano or a bar or something like that on top of them. But you've got that choice in panel thickness as well for spans, if that works well for your design.
Can they use that for a wet area directly?
You can, but typically what's done, if you're going to do a timber joist system like that with power panel flooring, then you use something like a thick sheet or like the really heavy fibre cement sheets. Have everybody seen those? So there's a few different product names for them, and put that down. That gives you a decent sort of step down. If you've got a 75mm panel, then you've got like a 20mm thick sheet going down, or then that's 55mm set down for your bathroom. You can put a screed over top of that and have your drain to your floor trap. So yeah, it's typical. You can, yes, definitely you can use it for wet areas, but there's just that benefit of using thick sheet for your wet areas and bringing your joists close together, that wet area.
On the floor, glue it and squish it together and screw fix it off. And the same thing with the wall panels. When you come into the Cementel product, it's the same scenario. Again, you're using carpenters to do the work. It's quick and efficient way of putting a building together, and you get immediate effects.
Really, the advantages you get is the guarantees that we provide, because we've done the testing on the connection systems and the jointing systems. So you really do have a much more comfort and peace of mind that you're not going to get cracking in the wall elements.
In designing with both Hebel and with Cementel products, from an architectural perspective, we get to expose the sculpture of the building much more.
You can already see how the textures are working together, and the advantage of using all CSR products is they integrate perfectly. If you'd like to find out more, check out hebel.com.au or cementel.com.au. And for other news on the house or to watch other webisodes, go to csr.com.au or check us out on YouTube. Leave us a comment or any questions. We'd love to hear from you. See you next time.
Once again, apologies for the sort of gratuitous marketing, but that's can't. Where's the third side? Can't so much get away from it. I've put a bunch of videos there. So that's the external cladding video. There's also the CSR house footings and Hebel. So that's more about the footing systems. There's a lot of crossover between the two videos. I won't show the other one in here today. Actually, what I will do, just quickly, it's not related to what we're looking at today. It's not related to Hebel, but I'll just show a small section just quickly because it relates to
major milestones.
Yeah, it relates to footings. So this is footings. We've covered footings already, but what we didn't look at, we looked at waffle pod systems, but we didn't look at this one called the Kupelex system as well, which is very similar concept. Basically, it's using void formers to remove concrete where concrete is superfluous, and so it's about being more efficient with your concrete. It's not really a system which is taken off, but it's still used.
Constructing a house is putting down the footings or foundations. They're not called foundations for nothing. They're the basis of a stable building structure. And if you don't get it right, you could end up with settlement, cracking walls, and water penetration. The three factors that determine what kind of footing you require is topography, soil conditions, and structural requirements. So whether you're building on a flat or sloping site, if you have soil with high clay or sandy content, or you need to add piers to deal with filled land, are all things you need to consider, not to mention the size and style of your house. For a two-storey family home like the CSR house, you're going to need a slope system which can accommodate the movement of the ground during prolonged changes in climate.
The main reason we're using a slab on ground on this side is because it's a fairly level slab. There's three types. There's a waffle slab or a stiff and graft we could use, and now the Kupelex system. If we were to go to a suspended slab, we'd have to do a lot of work to get up above the ground, and that's quite costly. We have to extra perimeter brickwork, whereas you can see on these perimeter slabs, there's no extra brickwork other than the work which comes straight off the slab.
Concrete has a high volume of thermal mass, which is really useful in regulating the internal temperature of buildings by radiating or absorbing heat as needed. Mass is useful in most climates, and particularly in cool climates or climates where there's a high diurnal range of nighttime or daytime versus daytime temperatures. However, thermal mass only works when positioned appropriately. You shade it from the hot summer sun, and you position it to attract the warmth of the lower range winter sun. So poorly positioned thermal mass can have disastrous results, whereas strategically positioning the thermal mass in the house can really aid the thermal comfort of the internal environment. So the CSR house has the slab in direct contact with the ground, which allows us to thermally couple the internal temperature of the house with the ground temperature. The ground temperature is more stable, which gives us the result that we use less energy to heat or cool the house, which is vital in delivering a sustainable home. The concrete slab that we've used in the CSR house is a variation on the traditional waffle pod slab. Traditional waffle pod slabs use polystyrene void formers. We're using a system called the Kupelex dome system. Kupelex domes are made from recycled plastic, and they're forming the domes or the voids underneath the concrete slab by basically forming volumes and pockets of air rather than being a full solid polystyrene block. Polystyrene is quite nasty on the environment, and recycled plastic PET that goes into the Kupelex domes is obviously a recycled product, so we have much less impact on the environment.
we can have a lot of flexibility in how we interlink the domes, whereas the waffle pod systems are purely void formers, and in accordance with the relevant codes, they should only be placed in single units with a concrete beam in between them. With these systems, we can do quite large areas, all interlinked with domes, which we call dome clusters, and we find that's a benefit in costs and speed of construction and ease of construction as well. The arching effect on the edges of the domes, and also inside the middle of the dome there's the cone shape, which gives them a lot of strength as well. The benefit of that is that every corner of the cupola dome bears onto the ground and gives it inherent strength, and it's like a composite plastic concrete structure which you can't get in other forms of construction for slabs.
So with the Cupolex dome system, basically the entire Cupolex pods were delivered on 2 pallets, whereas most traditional waffle pods using polystyrene, they need 1.5 trailer loads effectively of polystyrene. So you have less transport requirements, less waste on site, and less mess when you're forming when you're doing the preliminary works for the concrete.
For this project, concrete's a great choice. It's durable but quicker, easier and cheaper than a timber frame floor, and has many more thermal benefits. Where timber's a good choice for our sustainable home is in the timber frame. Timber's a renewable resource and has a much lower impact in its production than steel, making it better for your budget and the environment. It's thermally more efficient than steel, so it's going to save you money on your energy bills also. It's no coincidence 90% of residential construction is timber framed. So we've got...
Let's stop at that, because that's probably a lot of revision for everybody, and it's not too pertinent to what we're covering today. I just thought, yeah, because that Cupolex bit was coupled with this other Hebel video, I saw that the other night. But I'll show that in here as well, because it's another approach to a footing system, which is really innovative. So you have
good solid slab on our ground floor, but if you want to keep costs down.
So we have all those links here on Learn. So plenty of video links there, and have a look at them in your leisure. But also under that, so those ones are video links. That one's a video link. Actually, this one's a video. Yeah, we'll see this one as well, because this is about another application of the Hebel power panel. It's for intertenancy walls, because of its fire rating capabilities and its ability to be installed in a fashion which is independent of the support structure, and we'll see those details in a minute, makes it a really good intertenancy wall. Yes.
So in the first video, we see that they are making a steel mesh, and then by making the Hebel panel, they first created a steel big steel mesh, and then they filled it with the material, and then the slabs, they're very thin piece, and cut, they're long and thin.
Yes.
So they have a little bit of that mesh in them. So that mesh still works when it's like cut after cutting, it's cut it from the main joints. Initially it was in the form of a net, and that's when it was giving strength, I think.
Yeah.
And now the Hebel panels are cut in very small pieces.
Yeah. So what happens is all that mesh goes into the I don't know what you call it, bath or form or so. So they've got a great big tub with all the Hebel cement slurry in there that's expanding up. All that mesh goes in there vertically. So
it is cut vertically, not like this.
Yeah, and then they pull out the big block and they cut them all vertically, like that.
The whole mesh is still inside it.
So the whole mesh is still inside it. But what you get happening on site though, so you get 3 metre long sections. You don't always want to use 3 metre long sections. And also, as you'll see in the installation manuals, when you go installing them in a floor, you install them in a stretcher fashion like this. in a staggered way, like that. And then another one here, like that. And then, so it looks like brickwork on its side, basically. But that means that when you come to that wall there, you're chopping this one, chopping that one, and the mesh is sitting in there like rectangular sections like that. That means that you get mesh exposed on the ends. You use a protective sealer on the ends of all that cut steel, because you don't want that rusting and expanding over time, particularly when that's on the outside wall. So you'll get the Hebel going all the way to the edge of your timber framework. Then you have some sarking on the outside of that and battens, but you still may get some condensation and so on in those pockets. So you've got to protect that steelwork at the ends. But when it's made in the factory, it's all cut between the panels of mesh. And then I assume it's to account for the expansion and contraction, that uncontrolled sort of sizing of the panels, the outside bits are sacrificed. So those outside bits are cut off and just, I don't know if they're recycled or whatnot. Actually, I'll leave this one to roll, and I'll duck over to the storeroom and get a piece of Hebel. So while this is happening. Pass it around.
They install this steel ring and
Yeah.
they apply the gel kind of thing on the joint. Why they do just on the joint? It's that fire protection seal.
Oh yes, yeah. So they'll have a tooth joint between their Hebel panels, but to ensure.
Not the panels, the rails.
Oh,
When
Gardens are thing down.
it's like a U channel at the bottom.
yeah.
They only put the sealant at the where they were butt joining together the U channel.
Okay, yeah. So that's because you get just a slight crack in there, and with the fire resistance levels that you see expressed in the National Construction Code, you've got integrity, adequacy, and insulation. Structural adequacy, integrity, insulation. That adequacy, that means that structure has to stand up for a given time. So it has to maintain itself as a structure. The integrity, that means that no flames or gases can pass through that wall for that specified amount of time. Now flames, that's kind of easy to stop. Gases, it's not so easy to stop. You can have tiny little holes that, that have, when a building burns, you look at this building and think, okay, this is burning, there'd be some pretty noxious gases coming off of this carpet and that, polyfelt wall. There'd be, so you're not allowed to have any of those gases pass into another unit as well. So that means you've got to seal every single gap. So when you've got a fire-rated intertenancy wall, it's as much about the structure and or the integrity as it is about the structure and that insulation as well. That's one of the benefits that Hebel's got above things like blue board. So blue board is another substrate for render. Hebel, because you can have the adhesive on the end, because you've got thickness to the panel, and you can have that adhesive, it means those panels end up working together, and so you don't get, when you've got movement in a frame, it's less likely to be expressed straight through those vertical joints. So also with any solid type walling system, well actually even plasterboard, when you're doing really long runs, you need to have control joints in them. And you also have control joints throughout a building. If, say for example, you've got a building like this, which is actually made, predominantly the structure is large steel portal frames. They're large frames of big sections bolted together. Those portal frames basically provide the shell for this whole building. They work independently of the floor slab here. And so you'll notice around some of the portal frame stations, they'll have these diamond-shaped cuts, and those diamond-shaped cuts will line up with cuts in the floor slab. They're all control joints to enable those slabs to do a little bit of this, because everything in Adelaide does a little bit of this, like with the reactive soils. And so they have to do that a little bit. But if you've got walls, so a plasterboard wall, for example, or any form of wall going across something like that, and you've got a control joint in that floor, because the floor is designed to do that, then you have to carry that control joint straight up vertically through every other element that's being built above that. Because if you don't, and you do your plasterboard clad wall straight on top of that, it's going to crack directly above that control joint. That's not the only, I can talk about the use of control joints in buildings for quite a long time. The basic thing to understand is that control joints happen at certain intervals or at certain locations. It's important to understand where control joints, like when you need to use them, and that's something you work through with all your different building systems. But whenever you have control joints happening down low, you have to carry them up through. And that's the same even at times with intertenancy walls. The best intertenancy wall is where you don't have a control joint in that, because that is a vulnerable position. But sometimes, because of long spans of things, also, you do have to have control. Even sometimes you've got things like change in direction of floor joists. So you've got floor joists going this way, and then floor joists coming off in that direction. It means those two panels of flooring are going to behave differently under different stresses. You want to have a control joint in your flooring there. You'll also want to have a vertical control joint in the wall coming up from that. So where you've got these control joints in the intertenancy walls, you have to have a foam backing strip that's compressible. So those wall panels can do a bit of this and compress that foam backing strip. But that foam backing strip acts as a substrate or a backing for the fireproof mastic which goes on there. And that fireproof mastic is also a flexible material that can be compressed or stretched to a certain extent. And that's what they're doing there. Another thing that's used for sealing a lot of gaps for both bushfire prone areas and also in intertenancy walls is mineral fibre insulation as well. So it's one of those things which you can't burn, but it's compressible and will expand and spring back to help fill voids. Another thing about intertenancy walls as well, and it all depends on the style of construction and and what classification your building comes under. But the intertenancy wall has to carry all the way to the underside of the roof, unless you have a fire-rated enclosure above that. If you don't have a fire-rated ceiling and enclosure above that to create separate occupancy or controlled units within that, then that fire-rated wall has to go all the way to the underside of the roof to ensure that you don't have a fire happening in one unit, gets into the roof space and across into the other unit. The only thing you're allowed to have passing across your intertenancy walls are your ceiling battens. So you're not allowed to have any larger structural elements coming across. So, reason for that is if one unit starts burning down, those flames going straight up and burning the roof down, and that all starts collapsing, that doesn't go breaking the wall. And another thing you're not allowed to do is go fixing anything permanently to that wall. So you're not going to have, this is your wall and then you fix floor joists coming off that wall, because once those floor joists burn, or you can, but there's certain details. Those floor joists have to be able to drop away from the wall. They're not allowed to be fixed solidly into the wall and take chunks out of it as they drop away. Because if they go, burning through, dropping away, taking chunks out, well then the fire can spread into the next property. So yeah, design installation guide, that's what we'll have a quick look at now. And also, two options for today's class. Yeah, it's still not raining yet. So we've got the option of we take a walk down to have a look at the buildings that are being built down here, where they're getting some Hebel in, and there's some other interesting stuff like with the OSB sheeting and so on for bracing that we could show you. So that's one option. Or the other option is we go through the services slides extensively. That if we don't go through services extensively today, we've made a bit of a mention of air conditioning, and it's about you guys looking at the stuff yourself this week and also researching air conditioning like yourself, or vice versa. Or we go have a look at installation stuff. Do I have any preferences for one or the other? So I'll lump that decision on you. We can do a silent vote. I can pass around a piece of paper.
Well, we're not allowed to go into the site though. We'll just be standing.
No. So just walk around the street.
I don't know. I feel like the video showed, like the videos we've seen showed, like pretty.
Yeah. Pretty detailed.
Pretty detailed of how it's installed, how it looks, and all that.
Fair enough. Yeah. Cool. Yeah. Is that? Do we have any detractors?
And don't want to get caught in the rain out there.
Yeah, no, it's sort of one of those. Yeah. It's meant to come in around 10 o'clock today, so 10:30. Yeah. All right. Well, we'll leave it. But I do encourage you to, because that building site there has streets that bring you right up to the buildings, and you can wander around there without actually going on site. I encourage you to go have a bit of a look at things. So they're using Hebel for external cladding and intertensive walls. They're using a whole heap of things actually. But another thing they're using is OSB sheet for bracing as well. And that's something which has really taken off in probably just like the last 12 months or so, because OSB sheet is really quite cheap. You get a lot of bracing capacity out of it. And it's something that's been done overseas for a while, whereby they use sheeting products to clad the whole of a frame, to give that whole frame a real rigidity, but also seals air pockets in that frame. Because for a couple $100 extra, you can nail out sheeting all the way around the frame, and then you get extra insulation from that and a lot of rigidity out of that. So they're building 3-story timber frame places there, and the way that they're meeting those bracing requirements for those 3-story, because as you go taller and taller and taller, you've got a lot of leverage on a building. So your bottom floor has to have a lot more bracing, a lot more rigidity. That's what they've done on those buildings, and you're seeing that around a lot. Another thing you're seeing around a lot, but hasn't been used on those buildings there for intertenancy walls like this, is something called shaft liner panel as well. So that's plasterboard, which was initially designed for lift shafts. So it's fairly thick, impact-resistant plasterboard that's now getting used for also creating the fire separation for intertenancy walls as well. I think the reason we see a lot of that going in now is because it's cheaper than this. So you have two separate timber frames, not acting together structurally at all, and then you have shaft liner panel in between those with all the joints and everything sealed in between those. So to get the details about that, you'd either go to the Boral installation guides or the CSR Red Book. So yeah, what we decided is we decided to stay in here for this this lesson, and we'll go through the services. So there's a whole bunch of links here for some design guides and Hebel cladding, floor installation, flooring. Oh yeah, here it is. The CSR Hebel link. So that will take you straight to the web. Actually, we'll look at it just quickly. So hebel.com.au, downloads. So here, stacks of things to download and to have a look at, a lot of design guides. So we'll be looking at multi-residential. One of the things you'll see in the design guides, I have to find out exactly where the design guides are located again, but one of the things you'll see in them is you've got these system codes. So what they've done is they've got a product, and they've got a whole bunch of other products. They've got their top hat sections and all this sort of stuff. And they say, okay, with this system, you can achieve this particular thing. So let's say that the ATB 1900 to 1914, you get a fire resistance level of 90, 90, 90. That's an hour and a half of adequacy, integrity, and insulation. You'll get a sound transmission rating of between 34 and 58. For separate occupancy units in a class 3 building, you have to have that sound transmission rating of at least 50. So in one of those systems there, you've got to be able to use that in a class 3 building, and then information about all thicknesses. So some downloads there for the various different systems, but in your, and I'll have to find these installation guides, maybe it's in products. Okay, yeah, so design installation. So you've got all of your installation guides here for flooring, for walling, for all your multi-residential applications. We'll have a quick look at external walls, or some tendency. Go to the next one, see if we've got, it's Hebel power fence. Okay, we'll have a look at this one then, that'll include some flooring in that. So low-rise, multi-residential and commercial 75mm power floor. So all their panels, they call them power panels. Also, another thing about Hebel, and if you do a bit of searching around on the internet, you'll come up with Hebel blocks and also Hebel walling systems. Neither of those really took off very well. I'm not sure if you can still buy Hebel blocks or the Hebel walling systems. The Hebel walling systems were about having fat blocks that are keyed with some adhesive, and you just drop them on top of each other. It's like precast concrete sections that aren't as heavy as precast concrete, and you stack them all up like separate masonry units, except they're quite large. In a way, it makes sense, but it just never really took off. I guess because you've still got to batten out the inside for your plasterboard, and then you've got to meet your insulation requirements. Anyhow, so you'll see those online as well. Some of that information is older information. By all means, get to know it, but it's not going to be too pertinent because they're not systems which are readily used. So in here, you've got a bit more information about different installation systems. So we've got one for carpet, one for 8mm ceramic tiles, and then we've got these system numbers there associated with them, and then page number for your details. So if we go to Hebel Power Floor System number 1184, go to page 12 for our details. Just like that. We go to page 4. So so there you have some installation details showing you've got floor joists running perpendicular to your joins in the panels. You run a bead of construction adhesive. Then you use, set down your first panel and screw fix it into place. Flush those screw fixings with the panel adhesive. Put some panel adhesive on the ends. Drop your next panel in. Squash that into the key joint, etc. And then underlay carpet, etc. And then there's your various, so in that range, there's your various different details and your sound ratings. So the first one that's going to meet those sound ratings for your Class 3 building is going to be that one. So we've got commercial floor carpet, second story gyprock ceiling. So you've got a gyprock ceiling underneath that. Anyhow, work your way through these. Get to know your way around the design guides a bit, so you know that there are various different systems for various different uses and applications, and that all of those installation details for all the different approaches are there. So that's just flooring, but you've got walling systems, you've got walling details, all of these things, details for penetrations through flooring. Basically, pretty much every sort of detail you're typically going to require in the construction of a fairly straightforward multi-residential property, those details are in here somewhere. So have a good look through and that. Darcy asked early on about, do you use it for wet areas? And I said typically you use a thick sheet. That's that detail there. So for the Hebel floor, and then you use a thick sheet that can create that set down, and then you put your screed on top of that to achieve that.
Because if it was like a chipboard, I forget what you call it, like a chipboard. What did the floor like that? The frame actually
structure floor.
Structure floor. The frame actually has to be set down, but because Hebel is so thick, they're not using a thinner material for the wet area. It doesn't actually.
And then Steve the devil. There's also the option of creating set downs in your framing. Now, set downs in your framing, that's far more involved. There's a lot more work in that. Also, where you're going to do a set down in your framing, you're going to have changes with your joists anyhow. So you want a supporting wall. It's much simpler to do the set down with that thick sheet because, yes, your joist spacing will probably be reduced to 300 millimetres instead of 450 or 600 or 900, whatever it is for the thickness of your panel. But so your joist spacing is reduced. But if you've got a supporting wall at that point, well then reducing joist spacing is a very simple thing to do. But yeah, there are details for whatever approach suits you. And the reason people will use different approaches is because there are certain other design elements in the house which will flow on to reasons why you go with this way of doing it rather than another way of doing it. And that's all case specific, and that's where you get that enabling of, okay, well, we want to produce this feature, we want to produce that feature, we want to have this layout, etc. That's the design flexibility we've got. I'll just flick through them quickly to see if there's anything else interesting to point out. So various different details for suspended floors or upper or floors we have a change in cladding. So here we've got for our lower floor, we've got brick veneer cladding on the outside and then weatherboard cladding on the top. You know, a reason why you do that is so you provide some visual articulation of the building, some different materials. That's a very sort of postmodern thing to do, to bring 5, you know, different looking materials together, create a thing. But also another reason you do it is because you brick wall down the bottom here. If kids are running into that with their bikes or you banging it with your car to an extent, it's relatively durable against these sort of knocks, etc. Your weatherboard cladding is not so durable against things like that, but your weatherboard is really light. Typically, when you go up, and probably has everybody seen a pop top extension, or you know what that is? So with your older 1950s, 1960s houses, there was a bit of a thing, you don't really see it much anymore, where you got your old single-story house and people go, well, we don't want to move out, we want to make our house bigger, we want an extension, we don't want to go in the backyard, let's take the roof off and we'll build a bit on the top. So you see that around a bit. Typically you'll do that with weatherboard because weatherboard cladding is quite light and you don't want to be transferring a lot of additional loads onto your house that wasn't initially designed. It wasn't initially designed for. That's also the same reason why you use weatherboard for an upstairs, because overall the system is really quite light. You're not transferring a whole lot of extra load onto your frame beneath. If you were going to go with a heavier cladding, you're going to be like a Hebel or something like that, then you will be transferring more load onto your cladding. And Hebel will provide you that strength, that knock resistance, but you don't really need it on other floors. Treatment of details relating to treatment of moisture. So you're always going to have a little bit of moisture making its way into cavity walls. That's what cavity walls are designed for, be that moisture coming in through small gaps or condensation. That's another important detail to show. Once again, we've got a control joint happening here because we've got a joint happening in joists. Certainly the best thing is to lap your joists to a decent amount and nail through, so they're not going to be doing that. But if you've got flexibility happening in your house, that is going to be expressed where you've got joints happening in flooring structure. And also the other best practice thing to do is not have joints in joists all the way along, creating a thing, you stagger all your joints through. But where you've got a supporting bearer or a supporting wall like that, and then you've got some joists joining and you've got a series of them, then you do a control joint above that, so it has that flexibility rather than go cracking through any of your Hebel floor. Other control joint details, etc. Here, details for joining to different framing types. I think we've got details up here where you've got change in joist direction as well. I know that must be further down. Anyhow, so stacks of details for doing a bunch of things. And so you've got a bit of the sort of marketing material which you're going to plug it as a product a lot. Working through this and getting to understand the installation and the capacity and so on is going to give you a bit more of an idea of its benefits and its shortcomings. Primarily though, the major shortcoming of it is it's more expensive. So it costs you more for using Hebel than it will. So to do a timber joist floor with structure floor on top is going to be several $1,000s cheaper than doing a timber frame floor with Hebel on the top. That's the main driver as to why somebody would choose not to use it. Can anybody think of any of the benefits of it? I'll sort of make it simple by going to there's a section here with a bunch of things on it. You know, because obviously in their design guides are going to tell you about benefits, not the shortcomings. But yeah. It is, you know, it's relatively strong. You're going to get, what's that?
Easy to install.
Easy to install, yeah. So they're quite quick and easy to install. So is particle board flooring. That's also very easy to install. In fact, I'd say that's even easier to install, being quicker. But still, yeah, it's quite easy to install, much simpler than floorboards.
Sound isolation. Sound isolation.
Yeah, that I think is the major one. The difference between walking on a chipboard floor and walking on a Hebel floor, there's so much difference in sound and that transmission of sound through. Because Hebel is like concrete meets aero bar, it just doesn't transmit that. Well, get a bit of noise on that once you get cardboard on top of that, you know, but it doesn't really transmit noise through it like a particle board will. And also, I'll leave it open to you guys. What other benefits of it?
Especially vibration.
Yeah. Yes. Far less vibration happening through. Far less flexibility in the floor as well.
Because in Australia, I think the most affected things is the different food affect each other. You walk on the floor. Yeah, you can be.
Yeah.
This kind of things can avoid this.
Very, very important points. Anything else that would be good about it?
Fire.
Yeah, fire resistance. Certainly, yeah. You've got even if you don't require. Even if we're building just a single residence, so we're building a 2-story residence, and we get a fire that happens in the garage that has a bedroom above it or something like that. If you've just got particle board flooring there, well then that fire can make its way through, or you would get a fire in a bedroom underneath or something, right? That fire can make its way through, whereas the Hebel floor will stop that fire for a much longer period. It may not be designed as fire separation because it's the one single occupancy unit.
Time.
Yeah, it gives you time. Yeah. And also, so many buildings, when they get burnt by a fire, only get partially burnt as well. And so a lot of buildings do get repaired. So that's the work that I used to do. Well, for the engineering firm was repairing bits that have been burnt or impacted on or something like that. That happens quite often. Yes, there's extensive damage throughout the rest of the house with smoke, and you've got to use stain sealers and all that sort of stuff. But quite often it can be localised into rooms. With that sort of flooring, yeah, it might burn the joists or something like that, but you just don't get that passage of fire happening in the rest of the house. So another good, pretty important thing. One more thing.
How about recycling? Can we use it again?
I don't think so. It is essentially it's a natural product. It's all elements that do exist to a degree. I mean, you don't get cement powder existing per se in nature, but it's a non-toxic material. It's the sort of thing you could probably crush it up, and if it went into your garden, you probably wouldn't be too concerned about it. It's not like plasterboard when it breaks down, it gives off stuff and so on. That doesn't give off stuff.
Before the texture coat goes on there.
Yeah, so before the texture coat goes on there, yes, exactly. And it's all about what else goes on there. So essentially, I guess it could be recycled. You could crush it up and it gets, but really, yeah, there's not a great deal of application for it afterwards. But I guess it's the sort of thing that could go into the whole skip. It gets sort of squashed up and everything used for basic glass houses or roads or something like that. So yeah, recycling to an extent. I think the main thing would also be insulation. So it provides an insulative value about, well, it depends on the panel thickness, but for this sort of size panel, you've got an R value of 1.5. That's a decent amount of insulation that if you had just particle flooring, that you don't get. Or if you were to have weatherboard cladding on the outside, that's insulation that you don't get. And also provides a little bit of thermal mass as well, a little bit of regulation of temperature within the house, but mostly insulation. So work your way through those, and of course, yeah, like with everything, grab all those design guides and keep them in your filing system. Have that filing system where you bring all this stuff in, so you can be referring to it at any point in time. Might be quicker to open up a new one. So there's a bunch of other slides. There's also, so we'll be looking more at concrete. I've decided not to go through this stuff just yet. We'll look at that in the commercial construction because this assignment is due fairly soon. So we'll go through and we'll have a look more at steel for hot rolled sections, major use of steel later on. We may get a good look at cross-laminated timber as well. Cross-laminated timber is a very interesting thing. I think it's really cool to look at, but it's also something which hasn't really taken off in Australia more because of engineering capabilities and the certification of it. There is a factory which is being built for making CLT in Australia. Once that happens, then we'll start to see it flowing through. But at the moment, it's not a very important product in building yet. I mentioned earlier the CSR Red Book about shaft liner intertenancy walls. Stacks of really good stuff in that, but if you print it out, it's this thick. There's, it is a bit overwhelming. Have a look at it if you wish. What we're going to have a look at now are services. So, yes, as drafters, as building designers, we should not be telling electricians how to do their job. We should not be telling plumbers how to do their job. It's for them to say how they should do their job. But it's, it's in this format, that's interesting. But it's still important for us to understand their jobs. For what Thomas referred to earlier on is things have to be buildable. You don't want to go saying, oh, let's do this and do this and do this, not think about something, and then find out that you can't get stuff, like pipes can't go in there, things can't work. And it happens all too often where you get plumbers that cut floor joists, and they just chop a bit out of the floor joist and put a pipe through, and then that's their job done, and they walk away. You don't want that sort of thing happening. So it's important for us to understand the services. I'll go through these, try to go through these relatively quickly. I wonder if there's a better way.
I was actually doing some work setting up the garden on the Earthly Delights.
Oh yeah, yeah.
The food stalls are built from all the recycled timber. And the carpenters can't build it all, and then when people come to do the fixtures, people were cutting, strapping, and just cutting whatever they had to fit everything in. It was so funny to see. It was just all the not that much thought goes into it, but it's just funny how the carpenters can't do their thing.
Yeah.
And then it all just gets undone. Like, it's all so chunky, like all the years and years, like, and when it all comes out, they just pull all the timber apart, chuck it in shipping containers until next year, and then they pull it out and see if they can make it from the same stuff. Like, it's crazy.
Yeah. Meanwhile, bracing has been cut.
Especially when we were just like cut, and then there were just tubers hanging, and I was like, that is so ridiculous. But,
It's a bit Wild West. Particularly, I've noticed that in the garden, right? Like some of the jack build stuff. So services. So within VCA volume 2, we've got section on services, but then primarily in VCA volume 1, we've got section E that relates to services as well, which is typically more comprehensive than in your volume VCA volume 2. Things that we'll be dealing with, things like solar. So solar is something that's not going away. The future of energy distribution and supply is one of the things. It's a fairly interesting space to watch. It's centered around electricity. Fire suppression systems. Fire suppression systems is also something, of course, not going away. And this building here is a perfect worked example of why it's important to actually understand fire suppression systems at the design stage. Does anybody notice that, particularly near the front counter, the reception there? You come down the stairs, and it makes perfect sense to go around the stairs to go to the reception, except you can't. There's a fire hydrant and supply pipe right there. So it's important that fire systems engineers are brought on relatively early in the design stage. So you're doing this design, you work through this stuff, and say, this is where we're running a hydrant. We've got to have a hydrant here because we need 32 metres of hose to meet that thing. We need these particular spacings. This is where it works structurally, whatever. So, you want to, this was a major project. It's still won architectural awards. I'm not bagging the building. I think they did a fantastic job overall. But, you'll see that in buildings all the time. That maybe should have been seen at the design stage. Now, some of the reasons those things aren't brought in early in the design stage is because engineers are expensive. You don't want to waste their time. You don't want to spend too much on that. But in the scheme of a multi-million-dollar building, maybe it's not such a bad thing. So, fire suppression systems, good thing to understand. You definitely won't be designed. I won't say that. But who knows what you're going to go on and work as and do. Chances are you won't have a lot to do with designing fire suppression systems. Although, one of my current students in another subject does that. So, he's a drafter working for a fire systems engineer. So there are those capacities. Gas. So we have gas supply. Various different types of gas, mostly because of the supply available, like LPG or natural gas. Heating and cooling systems. So it's important that the heating and cooling systems work in the buildings. I don't know actually it's still not very warm today. I don't know if they sorted out the heating system today. Definitely, if anybody was here at TAFE yesterday, you would have known they didn't sort out the heating system yesterday. Anybody notice that? Anybody here yesterday? Gas wasn't on or something. There was some problem, something went. Anyhow, very little heating in the staff room. We were all wearing jackets. So heating and cooling systems. That's a base standard. People expect houses now to have heating and cooling systems. They expect that temperature to be regulated. Many different ways of going about that. One way, and a lot of the NCC is centred around an efficient house is a house which contains air of a temperature. That's one way to control the climate in a house, is to, let's say we're talking about winter time, is to heat the air. But another way is to use radiant heating as well. And you'll see it a lot at outdoor cafes, etc. I don't know if, I think down at the cafe down there they've got gas-powered ones. I'm not sure actually, have a look up next time you're at a cafe or the next few times or so. Some places you can see these black strips. They look like Yeah, like just like a black bar attached to something. They're radiant heaters. So they've got elements inside there that radiate heat down. If they were to heat the air in an outdoor cafe, obviously that doesn't work. You know, the air just goes away. So that's where radiant heat comes in. And there are various different ways. So you've got your old oil heaters, very inefficient with their electricity, but what they do is they produce radiant heat. So they heat things around them through radiation. And the sun heats us through radiation.
The orientation of building we can also control this heating and cooling.
What's that?
The orientation of building we can also control.
Yeah, most definitely. Yeah, most definitely. And yeah, I think certainly we've mentioned it a lot in this subject, but most definitely, the best heating and cooling you can get in your house is free heating and cooling. And yeah, if you've got that option of producing a house which has a decent amount of northern exposure with adequate eaves coverage to ensure that in winter time you get lots of sun pouring in there and pouring onto your slab and other elements of thermal mass, heating that up during the day and then giving that heat off at night time, that's the best possible approach. And then in summertime, have that adequate shading around the house, have plenty of planting so plants take moisture from the ground and they evaporate, and that evaporates off their leaves and foliage. That's like an air conditioner around your house. Or grapevines that allow sunlight through winter time and block the sun in summertime. Yeah. Or also other passive cooling systems you can have. Have I showed you the buildings in Iran? No? Yes. What's that?
Don't think so.
Don't think so? Right. Well, let's digress just slightly because this is pre-electric air conditioning. So the city of Yazd in Iran is known for it. So it's a desert city, but it's not just in Yazd. It's in a whole bunch of places. I haven't travelled in India, Pakistan, or Central Asia, so I don't know if these are features anywhere else in the world. No. No. Or whether it's more of a Middle Eastern thing, but I certainly saw it used a lot in the desert cities of Iran, where you have towers like this, and I'll see if there's a building cross section to show. Yeah, there we go. We've got this building cross section. So you have that tower coming up there, and on the windward side, wind can go into that tower and it's directed down, and it might be directed down into a cellar under the house, or sometimes even a big water tank. Right? So they'll build stone walls there and seal that, and then collect all their water under the house, and then that air is directed down into those cool rooms or the water storage, and then comes back up through floor grates, so that evaporative air conditioning comes through the floor, and from the top of the room, where all the heat rises to the top of the room, all the hot air, that's connected with the leeward side of the tower, which via a Venturi action, so as you get wind passing past that wind tower, it creates a suction on the leeward side of that wind tower. So all you need is a very slight breeze, and you get free air conditioning. And we're talking about very, very slight breezes. I was in a room. It was stinking hot, very indiscernible breeze. Yeah, I had a nap on top of one of those floor grates because you just got all that cool air sucking through there. Once again, best form of air conditioning is free air conditioning. Well, you get people that dispute that. You get people to say, no, the best form of air conditioning is my three-phase power reverse cycle air conditioner. The costs of mint, but that's okay, and I'll work a mint, and I can pay lots of money for perfect climate control. Differing perspectives on that, and I respect it. But this is 2,000 years old, this technology. So really old.
some houses are still built same back 100 years ago, 200 years ago, I think so. It's still there, but it's still
Yeah.
you can go ahead and see.
Yeah.
I've seen.
Yeah, in fact, I'm pretty sure there's a building out at Monarto Zoological Park that uses that as well. So I haven't gone in there to pick through it, but that's what I heard, and I can see that they've got these sort of things with louvers on the top. I think it's doing that as well.
In Chandigarh, now in modern Chandigarh, some architect name is Vishwendra Sujata. He's a very famous architect there. He built the terrace garden with roof coverings and with this reddish cover. The restaurant, terrace garden. So,
The Talus Garden.
Yeah.
Should we quickly look at that? Is anybody?
I think so. Yeah.
Yeah.
Yeah, Chandigarh Talus Garden.
Yeah. Is it Chandigarh?
Yeah. Terrace garden. Terrace.
Terrace. Oh yes. T-A-R-I-S or double R.
T-E-R-R-A-C-E.
Terrace.
Terrace. Yeah.
Ah, sorry. Yeah. My industrial deafness. So that's part of a major construction or big network.
Yeah, Chandigarh is the only city which is planned by an architect.
Yeah.
Yeah, the Corps.
Oh, the Kabusian.
Only one city is this. It's named as Chandigarh Beautiful Chandigarh.
Yeah.
Yeah. Now it's very beautiful. Like Adelaide, you can say.
Yeah.
More greenery there, more gardens, parks, everything is there. It's very beautiful.
And is it a place that attracts a lot of people simply because it's a lovely place to live rather than for economic activity or?
It's a rock garden by Lake Chand, I think so. Yeah. It's also rock garden is also very good.
Yes.
Very fresh.
So many uses around or applications around the world for very low tech. Low tech technology that is quite simple and uses no energy at all. That produce very comfortable ways of living and so stacks of those. That's right, PowerPoints. I think definitely we can still look back to sort of pre-industrial times, pre-advent of electricity, because the advent of electricity is absolutely fantastic, of course, but it's enabled us to be a bit lazy with design. Air conditioning has enabled us to be lazy with design. Heating has enabled us to be lazy or with very little attention to detail. We've got an understanding of orientation, etc., and the way that air works, like passive air conditioning or evaporative air conditioning. We can design places which are very comfortable and very energy efficient. Also, a very important thing in houses today, telecommunications and data. We had a talk. It was about last year, I think. So before many of you started, where I'm trying to think of their name. Can't think of the name of the company. It's not so important. Anyhow, there are home automation companies, and there's one company that's a particular leader in that. Anyhow, they did a presentation here about home automation. And they're going, this house, this place, they spent $150,000 on their home automation, so they can go party mode, the lights dim, whatever. Some people are doing that. I tend to think, $150,000, I might retire early instead. It's all each to their own, but still in you know, for a lot of your standard sort of houses, there's still telecommunications and data is a component and a consideration, and you have to think about where these technologies, etc., are going to be included. And certainly, if the client's saying this is what we want to be producing, that has to be thought about early in the design stage. Water main, annual collection sites, stormwater retention and detention systems. Very important consideration. So, do you have mains water on the site? So, with your initial inspection of the site, that's the important thing. Now, you don't need to go out onto site anymore to know if there's a mains water connection out front. You used to have to. Just go to SA Map Viewer and look for, you know, does it have a mains water line in front of it when you select that. But the reason that's very important in the design stage is because you have to make space for on-site water retention for fire, like we spoke about with the first time, but also just for household use. So you're going to think about how much water are people going to use? What's our annual average rainfall there? So multiply your annual average rainfall by the size of your roof. That gives you your catchment, your annual catchment. So 700 millimetres, say, for a 100 square metre roof, you get 70,000 litres of catchment per annum. And then you go, all right, now all your wastewater systems are designed at 150 litres per person per day. Now most people living on rainwater won't use 150 litres per person per day. But you can get a bit of an idea of, okay, do they like long showers, etc. Are they going to use 80 litres per person per day? Or also, and then work out how is that 70,000 litres of water going to get? Is that enough to get me through the year? Do I need to build more roof area to actually cater for the water collection that's required? Do we need to maximise our water storage, or are our occupants really, we're going to go like 2 bedrooms or 1 bedroom or something like that? Are we going to have, we design it for very few occupants? Can we minimise our water storage? So you've got to go through those calculations, and also the other important thing is, how do you get water from your gutters to your storage? On sloping sites, that's not always an easy thing, because councils don't like water tanks in front of houses. Certainly, you might be able to twist their arm a bit in that getting it through the design phase, saying, well, look, we have no other option, blah blah blah. But yeah, technically, councils don't like garages or water tanks in front of houses. They like the house to be the primary structure and that to present well to the street. So on a sloping site, you've got a tank higher than your gutters. How do you get that water to that? And sort of one way of doing it is having small collection tanks and submersible pumps and so these sorts of things. But important thing to think about at the design phase. Also, if you don't have mains water on a site, it's almost guaranteed you don't have a sewer system on site. So for main sewage. So for all of our houses around here, in metropolitan Adelaide, you flush the toilet, goes into the sewer system, goes down to one of the 3 or 4 treatment plants that are in Adelaide, and I think it's very unfortunate. A great deal of that just goes out to the ocean, which I think is a horrendously wasted resource, and there's plenty of people that think the same thing. Some of it goes to Bolivar, so there's a massive treatment plant out at Bolivar. That goes on to all your market gardens at Virginia and Two Wells and McDonald Park and all that sort of stuff. So it's used for growing food. I think much better use than going out to seed with each time, because of course there are cost considerations and infrastructure and everything that goes into that. One really interesting thing I heard just recently is, I can't remember what the SA water power bill is, but the SA water power bill is huge. It's actually uses 1/3 of the electricity usage of our metropolitan area. So for all the electricity used, 1/3 of that is used by SA Power Networks. By SA Water for pumping water, providing water pressure and for moving sewage. There's a lot of energy that goes into that, which is another environmental thing. Think about how all that energy going in there. Like, it's something that we sort of take for granted. You turn on the tap, there's pressure. That pressure, that's created by having big header tanks and water reserves and so on up really high in locations, and then that provides that head pressure for water plus pumping stations and things like that. But it's something that people don't often think. Anyhow, they have a huge electricity bill. So that's with most of your houses, they have that sewer system. You just hook into the sewer system from the point of connection. SA Water have responsibility. Before that connection to their service, then you're responsible for that plumbing up to that point. That's very simple. For on-site wastewater, that has to be designed in accordance with the SA Health on-site wastewater design guidelines. So if you were to put into Google SA Health on-site wastewater, you'll come up with a document called the SA Health on-site wastewater design guidelines. And look, I encourage you to read through it to understand it. It's excellent stuff. As I said before, you don't tell electricians how to do their job, you don't tell plumbers how to do the job, you don't tell wastewater engineers how to do their job either. But, well, for example, what I've just done is worked with wastewater engineer to do a whole bunch of stuff for them, saves a lot of time and money in understanding that, but it also means that in the design phase, I can think about where I'm having the sprinkler system, where I'm having the circuit system, how much area I need to allow for all of that to happen. So in the design phase, I can go through and be designing things and then send it to the wastewater engineer knowing there's space for doing what they need to do. And that their design can work in with the whole design that I have for the place. So it's important to understand for that. It's also highly important to understand that if you're going to be doing any work in the hills, any development work, particularly in the Adelaide Hills or in sloping areas, that there are constraints around the slope of land. When you get greater than a 20, I can't remember off the top of my head, but 20-degree slope, so at a certain slope, you need to start doing retaining walls and soakage trenches. That is expensive. So I looked at a place that had a pre-approved design for a place up at Montague. It was going to cost $600,000 to build a 2-bedroom house there. Part of that's because of access to materials and things like that and the design. But a major cost in that was actually the on-site wastewater, how you deal with that. You know, a lot of people might think, okay, you spend $15,000 on an aerated septic system, that's it, done. There's actually, on steep sloping sites, there's a lot that goes into the trenching and retaining walls. The different types of soil that you have, if you've got a really heavy clay soil, it doesn't percolate very well. That means it doesn't accept the moisture very quickly. If the soil doesn't percolate well, it means you need to have a much larger soakage area. You now have a really big soakage area. So your different soil types are going to have an impact. But the biggest one that will say, can you build there, can you not build there, will be your proximity to a regulated or a registered watercourse. So on SA Map Viewer, you can look to see which watercourses are mapped as, you know, this is actually a watercourse. When you have a watercourse, you can't have your house within 30 metres of that watercourse. You can't have your septic tank within, I think, 30 metres of that, and you can't have your septic soakage within 50 metres of it. So, yeah, there's a site I was looking at, worked through it, can't be built upon. Like, you know, there's a sale, it cannot be built upon because of that. Well, the only other option is to do on-site wastewater storage tanks. And then you get someone to come in and pump them every now and again. You know, that's you know, that's going to be well too expensive. And you can do a composting toilet and then have some storage or whatever. You still got to have showers where you don't have to have showers. There's all these design things. But for your general design, whereby you have wastewater, some sites just can't do it. And so it's important to understand the on-site wastewater guidelines for that reason. The other consideration is bores as well. So one, water supply. So you can catch rain, water from the rain. Another supply is you can sink a bore and you can tap into. So we have groundwater here. We have groundwater at different levels and different qualities of groundwater at all these different levels. You get somebody out to drill that bore. Well, first of all, what you need to do is you need to apply for that bore. And there are holes on some places in the Adelaide Hills at the moment where the regulating authority are not allowing any more bores, and that's an important consideration. But if you go through that process, you apply to put in a well, it's called a well when you do a bore, and you pump water out of that, you can't have your septic soakage system, or nobody can have their septic soakage system within 50 metres of that bore. If you've got a property, and I've seen that with another place that had, I think, 6 bores on the site. It's a place at Woodside. It's got a 4,000 square metre site. Went on, actually I inquired with the council, went through that to get the information on what boreholes are on the site. There were 6 boreholes on that site, which basically meant you can't have an on-site wastewater system on that site. So once again, it can't be built upon, can't be developed. So there are certain things that will knock a project on the head that are incredibly important to understand at the start. So proximity to bores, proximity to registered water courses, and also your topography constraints and your soil constraints as well with your on-site wastewater. That's it. Is the idea of bore water familiar to most people, or yes or no? Yeah. So, everybody heard about the aquifer recharge that happens in places around Adelaide, as well out of Salisbury and Mawson Lakes. Anybody heard of that stuff before? Was that?
Can you repeat it?
Yeah, the aquifer recharge. So it's about understanding how there are sections in our soil and stone and cavities in there that will take water. Now, typically, what happens is you drill a hole, you put a bore pump in there, you suck water out, and that water it filters through the hills, and it takes like 1,000 years to come down through the rock or whatever. I'm just putting that figure up there. It takes a long time to come through. That's one way of doing it. What they've done out at Mawson Lakes is they realised, okay, there is that water table there. We can use stormwater and some controlled water to go down into that aquifer, into that water. So they drill a hole to send water into it, not to suck it out. So that can fill up more, so they can suck more out later on. So they're using that as a massive water storage underneath Mawson Lakes. So I think it was very fantastic, very progressive idea by the city of Salisbury to go, okay, well, we can put water in there to take water out, and we can just use that. So yeah, out around Mawson Lakes have been fairly progressive and innovative with water, in terms of that aquifer recharge, also the wetlands out there, water filtering, water treatment and so on. And that's another bit. In the SA Health on-site wastewater guidelines, you'll see sections there about different septic systems. So, and you'll have septic system suppliers which are approved. Going through that list, you'll see, like Biolytics and FujiClean and all these, and Biocyclones, all these major aerated septic system suppliers. They'll all be there. But then you've also got at Bendigo reed beds. So, and there was one local company called Septec, based in Stratharden, who did a sand filtration system. I think it's fantastic. It's a bizarre thing. They can't get certification because they don't have a maintenance schedule. Well, that's what I've been told. They don't, because what you also need to have is a maintenance schedule, and that's another important consideration about on-site wastewater. Is typically you need quarterly maintenance, and it costs you about a bit over $100 each time, so around that $400 to $500 a year maintenance cost just for that aerated septic system. And so there are various different systems to get around that. Talk to your wastewater engineer about those. But yeah, Septec uses sand filtration system, which is actually very old technology, but very reliable technology where you have just a big bed of sand, sewage goes in one end, clean water comes out the other end, and the magic happens in the middle there. Somebody in the room might know more about that sand filtration process. And then with your aerated septic systems, it's about encouraging the microbes to break everything down. The microbes eat everything and so on, and then make that relatively clean water. And reed-fed water filtration systems. Is anybody in this room familiar with a reed-fed water filtration system?
Yeah. More or less, it's basically what happens in wetlands.
Yeah.
But it would be very similar to the sand one as well.
Yeah.
And with an addition of microbes, so like you got all your reeds, water flows through that. The reeds will pick up all the bigger pretty much, and then through the other side of the reeds, that's where you would typically get all of your insect life and bacterial life that cleans up everything else, and then basically you just got to get all the bacteria out.
Yeah, and like, I don't know, digressing on a bit away from buildings, but that our bodies are full of microbes. There's, within our gut there's microbiota, and it's all, hopefully it's all in balance. It's all doing the right thing. Actually, I think we've got more bacterial DNA in our bodies than we actually have our own DNA. So everything like has microbes, and so much is about that interaction, that balance of microbes, and how they all work together. And soil science is around that as well, because what the bioavailability of nutrients, all that sort of stuff about microbes. So microbes are incredibly important, and that's what's happening in the reed bed water filtration system. Yes, you've got the sand filtration element. It's like the aerated septic system meets the sand filtration system all in one. And that's what the aerated septic system relies upon. It's all that microbiota that eat everything, and they do that properly. With any of those systems, you have to have them chlorinated at the end just to ensure that all the bugs are killed off. Various different opinions about whether that's a good idea or not a good idea. That's currently the rules. But yeah, there's a place called the Food Forest out there in Gawler. They've got a reed-bed water filtration system on their house. They show how that happens. Working through those SA Health wastewater guidelines, where it says which companies are registered, you'll see these companies in there. And so if your client goes, yeah, I want a reed-bed water filtration system, you can go, okay, well, we can refer to this company who has all the certification and all the designs, etc., for doing that. This is what they need. It's a possibility. Can anybody think why you wouldn't have a reed-bed water filtration system?
Takes up a lot of space.
Yeah, heaps of space.
The right topography for it to work by itself.
Yeah. Other main
Takes a long time to establish.
Does, yeah. It takes a long time.
The one that was next to my school took literally the entirety of my high school year for them to even finish building it. I think it's still being established.
Yeah. Look, you're not going to have somebody with a reed-bed water filtration system that doesn't know they have a reed-bed water filtration system. It's not like your other systems which are switch it on, whatever. It's like, I didn't know we had a septic thing. Yes, it requires maintenance, it requires involvement, it requires time. The other big thing is it requires constant water as well. if you're going like, well, I work in Singapore for 6 months of the year, and then I'm back here, it doesn't, and you come back, your reeds are all dead because there's no water going through there in the summertime. It has its limitations. I think we've, pretty much covered everything there. I'll go through these bits fairly quickly. Big part of repairing houses and so on is, well, a big part of damage to houses actually happens from plumbing. So we've got movable soils, we've got pipes that go through things, they get cracked, they leak, they soak into the soil, they make the cracks worse. And there are massive health ramifications for people who live in buildings with mould, etc. So there's carcinogenic links and all that sort of things, but also gut health and all sorts of things. So that's why we have SA Health on-site wastewater guidelines, etc. So with your plumbing, it's important that it's serviceable, that when you've got pipes travelling horizontally through slab beams, they're lagged around that to enable that movement. Lagging of pipes is incredibly important, and also the pipes aren't damaged through the process of laying the concrete, which happens sometimes as well, so it's good to monitor that, and that's happening. Plumbing, you've got AS 3500, got 0.1, 0.2, 0.3, etc. I can't remember which is which. I think 0.3 is for roof, plumbing and stormwater. Anyhow, I can't remember which point is which, but you have a specific section or number of AS 3500 that is for wastewater plumbing. Within that, let's call it AS 3500.3. Within that, toward the end, you have a whole lot of indicative installation diagrams that show your common pipe sizes. Now, pipe sizes relate to expected flows and gradients, etc. That's for the plumbers to be working out. Seriously, it's not something that you put on your drawings. You don't say, we're running a 65mm down pipe from our floor trap and 40mm from the hand basin and a 65 from the shower to 100 at the toilet. That's probably what's going to happen, but it's not for you to say. But what is for you to do and to understand is exactly that. To know what pipe sizes you've got happening where, how much space do you need? So what size is it? What's that? Do we have an S trap or a P trap on the end of it? How much space do I need for that? And is it travelling a distance? If it's travelling a distance and it's falling over a section, how much space do I need for that? That way, if you've thought about all those things, then you're significantly reducing the chances that you get a plumber on site who just cuts through the base of a floor joist to run a pipe through, because you've designed it so that that pipe is running through that floor joist in the centroid of the joist. So it's important to think about these things. It's also important to think about things when you're doing two-storey construction, to think how your waste stacks are going to work and where you can run that waste stack. So you think, okay, we're bringing everything together. Typically, everything's brought together with the floor trap of the bathroom, then from the floor trap, that goes to the toilet. Toilet has a 100mm pipe coming out the back of every toilet. All your other pipes pretty much join into that, where you've got an inspection point happening there, and that 100mm goes wherever. You have to design for that 100mm. How that, because if you've got a 90mm stud frame, a 100mm pipe doesn't fit in a 90mm stud frame. So you've got to think about that and think about, okay, where are those plumbing stacks running? Also, you need to have vent pipes at the head of a run of plumbing. That has to be ventilated. The reason it has to be ventilated is if you don't have a vent on that, when the water goes down that stack, it sucks all the water out with it. And it sucks all the water out of the traps and we have a trap, trap to show you. Yeah, so that's your P trap, that's your S trap. So tip it on its side, that's why they're called that. That keeps water in there. The thing about that water seal is you've got all sorts of bad smells and everything happening in that plumbing further down the line. you don't want to know about it. You don't want those bad smells coming back through. The way to stop those bad smells coming back through is to have that water stop there. So none of that gas can come back through this way and smell through your house. You have to allow for that P-trap in your floor, and yeah, you have to allow an S-trap in under your hand basin, etc. if that's on a separate run. But the venting at the head of that run ensures that water stays there, so that it doesn't get all sucked out. The water just flows down from there, and air can come back in here to replace the water that's flowing down. With your vent pipes, I'll go back up. So here we've got a vent pipe coming up there like that. You don't want a vent pipe going in front of the window. So some design constraints around that, some design decisions with that. But yeah, as mentioned before, it's good for you to understand these things. You don't need to specify them. It's about the plumber specifying them. It's good for you to know how the plumber will specify them so they don't interfere with your design. But you must be licensed. You must be licensed as a plumber. You must be licensed as an electrician and a plumber gas fitter. So you have to be licensed to do any of that stuff. And then when you've done your installation, or when the plumber or the electrician have done their installation, they provide a certificate of compliance. Those certificates of compliance, in fact, you might be able to get someone to do a paper certificate of compliance, but typically they're done as an electronic certificate of compliance. Now, that ECOC, that's, I don't know, maybe it's the Office of Consumer and Business Affairs that keeps them. Anyhow, somebody keeps all of those ECOCs on file. So at any point in time, if there's a question of, did you have a licensed plumber do this work? You can say, yes, I've got this, well, I've got an address of the property. Let's find out what that ECOC is. Yes, it was this person at this date that did this work that said it was okay. So all that's kept electronically. Now, it's much better than the previous system where it was paper, plumber keeps one, you keep one, you have a house fire or something like that. It's gone, plumber's gone out of business. So sanitary plumbing, gets all your waste away from the building. Designed in accordance with the AS 3500. So carried by water, so water carriage system. Nothing. Certain topographies in consideration. You need to have falls in your plumbing. You need to have things like an overflow relief gully. That overflow relief gully has to be 150 millimetres beneath your floor level. How you can get an IRG at 150 millimetres below your floor level takes a bit of consideration and thinking about landscaping and where that's going to run. The overflow relief gully, that is, and probably everybody has seen one, it's one of these little black grates in a 100 mil pipe that pops up out of the ground. Has anybody ever seen one of those? Quite often you've got a tap over the top. And sometimes you might have a bowl or a drain, a tun dish around that as well. The reason you have a tap over the top is because you also have a trap in that bit as well. You don't want stinky smells coming up through that plumbing. So if that trap dries out, you can turn the tap on and get water happening in there again. But that overflow relief gully, that's just in case there's a blockage further down and you flush the toilet or so that all that waste pops up outside the house, out in the garden, rather than inside the house. So it's that safety measure. You don't want all that stuff coming up through the floor trap of your bathroom or something. So that's the septic sand filtration system. Great idea. My neighbours have got one. I wish I had one, but they're not available anymore. But hopefully, maybe available again. Common effluent. So common effluent is where you've got properties that come together. Now that common effluent might be government owned. So just until recently, Yankalilla Council owned the common effluent system for the Warina Cove development. So does anybody know the Warina Cove development? So golf course and houses and things there. They've got a common effluent system for all those properties. Until recently, that was owned by Yankalilla Council. They just sold that to SA Water. So now it's come under the banner of SA Water. By and large, the majority of all your sewage is taken care of by SA Water, and that's all paid for by your water rates, and they charge you. So if you're on that system, that's what they charge you. But there are some council-owned systems like that one down there, or some privately owned systems where you've got places, maybe you've seen it on the river. You mentioned having been involved with the river, or living in the river or so previously.
Right near where our house is SA Water treatment.
Oh, it's an SA Water owned by.
Yeah, but for some reason, like so up the hill from where we are, it's like subdevelopment, like some home subdevelopment that all goes there, but for some reason we went there, so we have like EnviroSite does everything itself. It's like clean water, I guess, because there's also main water that goes right through within the X amount of meters of everything, so there's a whole bunch of so,
yeah. So for various different reasons, like pumping and systems, whatever, or when the development happened, SA Water weren't on board to supply set mains sewer to that property, so you've got to have an on-site septic system, etc. But also another thing that happened down along the river a lot, so all your river shacks, there was a point in time, it was around the year 2000 to 2002, a lot of it happened around then, some of it happened earlier, some of it happened later, some of it didn't happen for various different shacks, whereby those shacks are on a form of title called a Crown lease. Well, many of them were. That Crown lease, that's a 100-year lease. And so you don't actually own that parcel of land in freehold. You lease that parcel of land for 100 years, so you rent it. Now, that rent might not be much. It might be a paltry sum. It might even be what's called a peppercorn lease, where you have to pay one peppercorn annually for that lease. Nobody's going to chase it up, right? But you need to have, for legal things, you need to have some consideration paid. So these shacks are on leasehold basis, and they're on Crown leases. The state government don't want to have that anymore. They don't want to manage that. What they say to those owners is they say, we'll enable you to freehold that parcel of land. You pay us $15,000, $20,000 or so. It wasn't very much at the time, very, very small amounts. They said, we'll allow you to pay us this money to purchase the freehold of that land. We'll create a separate title, we'll do the survey, create a separate title. And you can purchase that. What that means is that those people who are previously on a Crown lease, that have purchased the freehold off the state government for that parcel of land, all of a sudden they can borrow money from the bank on the security of that land. Previously, when it's a Crown lease, they can't, because the banks go, well, look, we have no security of tenure. Like, we can't lend you money because there's not separate title created for that part of land. As soon as there's separate title created, people that own that, they can borrow money. And so there's a massive incentive there for people to do that, because they might have bought their river shack for $20,000, but it's a Crown lease, cost them $15,000, blah, blah, blah. All of a sudden it's worth $150,000 because they can borrow money against it. They can use it as security. So, but one of the considerations that the state government typically put in place for all these places is that any of those houses that's under the 1956 flood level, you have to put in a common effluent scheme. Or what you have to do is you have to pump your sewage uphill. And the way to do that is with a common effluent scheme. So you get together with all the other shacks in that area, you all plug together and pump up to some waste treatment situation up on a hill away from the river above the 1956 floodplain. So the 1956 floodplain, that's seen as a bellwether for this is as high as the river will ever get. Sort of. Okay. So along the river you have these dotting spots of commonly owned wastewater treatment systems as well. It's not very common anywhere else, but it's something you get on and that's why you get those ones along the river. But in the main, it's major SA Water owned sewage treatment plants that do this, and then septic tanks. So we spoke a bit about on-site wastewater in terms of sort of aerated systems and and then rebeds, etc., the sand filtration systems. Another way to do it, if you've got fairly porous soils, and you can't really do it with heavy clay soils, but fairly porous soils, is you just have a septic tank, which is a tank with 3 chambers in it. It collects the solids in the first chamber, a few of the solids make it to the second chamber, but by the third chamber, it's all very broken down. It's all fairly safe material that's had a lot of microbial activity break it all down, and that goes into pipes that soak into the ground. And that's all. So you've got that tank, that chamber there, and that all soaks into the ground. With your septic tanks, you still need to get them pumped every now and again. And it's not because they get too full and the ground isn't so, that can happen, but the main thing is you get solids that the microbes don't break down. So minerals, all this sort of stuff ends up collecting in there. The microbes can't break it down. It doesn't get carried through and soak in the soil. So you have to get them pumped every now and again when they start being ineffective. So that's a cross section of your typical septic tank. So it's this sludge that gets pumped out, however often, depending on the usage. So mentioned overflow relief gully. So that's an IRG there. So that's set down 150 millimetres below our floor level. We have our concrete slab there, our first brick, and then our floor level will be at the height of that first, at the top of our first brick course. Various different traps and joining pieces and gullies and T-pieces and things like that. That's your typical plumbing run diagram. You've got things like IO, that stands for inspection opening. So you have to have inspection openings at certain intervals, but also at certain places. So you can have an inspection opening close to your toilet. The reason for that is like little kids put soft toys and whatever in toilets, and that's
Balls.
Was that?
Balls.
Yeah, balls, balloons, whatever fits and plugs that 100 mil drain nicely. So you've got to have an inspection. So here we've got WC, that's a toilet, inspection opening right outside of that to enable that cleaning. And then you have traps at various locations as well, or overflow, or ORGs, overflow relief gullies, included in those plumbing runs as well. So that's taken directly from AS 3500. This one's also taken directly from AS 3500, so that shows you your typical sort of plumbing runs, and it's giving some suggested pipe sizes here. So we've got a 100 mil pipe, then we've got a 65 mil pipe that's picking up the shower and hand basin, etc. So you can get an idea of what your pipe sizes are, and then also there's information in there about what your falls are going to be as well for various different situations. Right, but so that's our plumbing. I'll move through fairly quickly. Electrical. So SA Power Networks are the authority that regulate your domestic electricity. So we've got also in South Australia we've got SA Power Networks and Electronet. Electronet do all the really big stuff, all your high tension, those big triangular shaped power lines. That's Electronet. They own all the major infrastructure. SA Power Networks own all the small infrastructure, all your 415 and 240 volt stuff. So whenever you get a connection happening to your house, you've got to be dealing with SA Power Networks to get that connection to happen. Now, you might have very little involvement in the process. You might go, okay, you choose an electrician and you choose an energy provider. You phone up the energy provider, or you fill out the form, send it through to them and say, I want power at this place. This is his address. This is the electrician that we're using. I want 240 volt power, this many amps, etc. Well, maybe you can get the electrician to fill that out for you, whatever. Send them off to your provider. They will manage the process because they will then also put their meter into your meter box. If I was to go to with Origin Energy, for example, Origin Energy put their meter in the box, and then I'll have a contract with them. Now, it might not cost me much to get a new energy provider to go and change over and put their meter in the box, but there is a bit of a changeover, there's a bit of an impediment. they're happy to manage that process for you. So that's typically how it's done. Your energy supply, you choose a retailer, and the retailer can handle that process for you in conjunction with your electrician. And your electrician will be in contact with SA Power Networks. Now, you may have an electrician who is registered to work for SA Power Networks. That means they can do a lot of that work. You might not have an electrician which is registered to work for SA Power Networks. That means you've got to pay SA Power Networks to get somebody out to do things. It can be a bit more expensive. Depends. Anyhow, there's a bit of to and fro happening there. You can be involved in the process or less involved in the process. Majority of your electrical supply is going to be either 415 or 240 volt. 240 volt is what's called single phase, where you've got a single wire coming through. Oh, I think there's an earth in the conduit or a return in the conduit as well. Anyway, you've got, but it's one phase of supply to your meter box. The other typical installation is 415. That has 3 wires coming in, so 3 phases coming in. Some commercial cookery stuff, arc welders, like big arc welders, massive air conditioners require 415 volts, hence 3 phases. Not every electrical supply in location will provide 415 volts. Some places you can't have that massive evaporative cooler on your your massive refrigerator cooler on your roof, because you can't actually get 415 volts at the property. Or if you were to say, if that networks we need S415, it might be very expensive for them to upgrade their infrastructure to supply that. That's the mainstay. There's some variance in that, but won't deal with that. That's the mainstay. Although also another very important thing for consideration in design, also particularly in rural areas, is the distance that you run power to. If you've got your stirred pole here and your meter box there, you always have to have, with rural properties, you have to have your meter box within 10 metres of that boundary. So, so if your house is 50 metres away from that boundary, then the meter box has to be within 10 metres of the boundary. If your house is within 30 metres of the boundary, then SA Power Networks will sometimes allow you to put the meter on the house. But you've got that meter box there, and then you want to run power 500 metres to where you've got a fantastic house site that has lovely views and things like that. It might be cheaper for you in that instance to use batteries and solar panels and have an autonomous power supply than hooking up with the mains. The reason for that is, yes, trenching is expensive, laying conduit is kind of cheap. And trenching with sand might be a bit cheaper, but it's the cost of the cable to run from one place to another, because what you get over distance is voltage drop, and as the electricity passes through that cable, you get for a long distance you get a lot of voltage drop. The way to counter that is to have a very fat cable, so you get less voltage drop over the distance. So the longer the distance you have to run, the fatter the cable. So it becomes a lot of copper. So yeah, it becomes a lot of copper, and so exponentially, the further you are, so let's say 500 metres, you have to run 500 metres of fat cable, whereas 300 metres, you're having to run a thinner cable and you're only running 300 metres on it. So it's exponential. So the further you run, the more expensive it gets. That might determine your house site, or it might determine whether you go for an autonomous supply. Like solar panels, wind turbine, and batteries. Some places also, so larger stations and things like that will have diesel generators running. Some places still do that. They have diesel generators running all the time.
What about the cost of getting another that stove pole in rural lands? To get a line installed to be closer, is that pretty expensive?
It is pretty expensive. Last time I checked, which was probably about 15 years ago, it was about $10,000 per pole. Yeah. So for that, it's a long time ago. It's probably a lot more. In fact, SA Power Networks, they've really gone up like a lot with what they charge for their infrastructure. It's sort of, it's a funny story, but it's sort of like a monopoly. You can't go, oh, SA Power Networks is charging me too much, I'll go to Bob's Power Supply. That doesn't, no, you've got the one supplier. Yeah. So, yeah, that's quite expensive, but definitely worth checking out. So you contact them and say, this is where we need to be running power to. What's it going to cost us per pole, per distance to get that supply in? They may be conducive to that, they may not be. They may say, no, you have to have your meter box here because we don't want our meters travelling that distance. Even though we're going to a system of smart meters now, when you put a meter in, the mainstay is you have to put a smart meter in. Smart meter can read your meter and send that information off through Wi-Fi. You know, nobody needs to kind of read it. Anyhow, SA Power Networks is still saying you've got to have your meter box here. And if you've got to have your meter box there, that means that, you have to run power. So I won't go through all this. Much of that is fairly obsolete, and you won't need to know it anyhow. There's terms like over to under, etc. You know, you can get power from a stone pole that goes underground, over to under, etc. The power supply running, so at the stone pole, for a lot of older installations, you have a service fuse on that stone pole. At the point of the service fuse, everything before that, SA Power Networks owns. Everything after that, you own. So if you chop it with your garden spade, you have to fix it, not SA Power Network. We have to pay for it to be fixed. But if a tree falls on it and takes out the stone pole before the service fuse, then SA Power Networks have to pay for it. From that service fuse onwards, it's called the consumer mains. So it's mains power, but it's the consumer mains. There are different considerations around when you're building in proximity to power lines. If it's SA Power Networks infrastructure, then there are certain rules you have to abide by. If it's consumer mains, there's less controls over that. Obviously, you don't want to go digging holes and breaking power cables, but different responsibilities. Sometimes you've got the service fuse on the stone pole, sometimes it's actually in the meter box in the house. SA Power Networks own that infrastructure to that service fuse. So where the service fuse is. So we're pretty much done for the day. I can't hang around for much longer. Next week I'll touch briefly on our air conditioning system. So we've pushed that assignment due date back to the 17th, so it gives you an extra week. Look, you can probably, it's piece of cake, probably do it all without introduction and discussion on those air conditioning types, and a lot of that information you can get from the internet anyhow. But we'll have that discussion next week, so I won't hold you up to further. Yeah. Unless there are any questions.